Hello there everybody and welcome to this R plus task tutorial. So we can use R plus task to program really any robotics robot. Here you can see the robotics Dream, the Dream 2, the Mini, the Premium, and all kinds. In this tutorial we're going to be focusing on the robotics Mini, but it should work with really any robotics product. So R plus task is divided into two things, into the programming and also into the motion programming. I'm just gonna load this here. So you can see that the programming is really just like any programming environment. We can define variables. Um, let's say bar equal to a number. It's gonna be 5. So it really just works as any other programming language. The motion it's a little bit more specific, and it basically just allows us to define the motions using a timeline. You can see here on top we have a timeline of different motions and it animates them. In this tutorial we're just going to be focusing on the programming. So like I said, we can program this basically the same way that we would program anything in C++ or in Java. And it's mainly here on the sidebar, so it is a visual-based programming environment. But you can see we have just if, else, conditionals, we have loops, and we can define our own functions. So for this first example, we're gonna be seeing how we can call these motions that have already been defined. These are just the ones done by the example project. So we're gonna see how we can call these functions or these motions inside our code. And for that, we'll use an execute and a load command. So you can see this is basically just like defining a variable, but we can really use it to access any part of the robot. So I'm going to just go here into the first part, and you can see that, yeah, we can make variables or numbers, but then we can also access the dynamixels or the controller device. And here under controller device, you can see we have motion, and we can do the motion index number. So we could set that motion index number to any of the numbers here. So for example, the initial position would be 0, get up would be 1, sit would be 2, etc. But just to avoid any confusion, we can also just use the motion list and get them here. So for example, motion 3 corresponds to sit. They are 1 index, not 0, so that was my mistake. But here we can see that motion 3 is sit. And one very important thing is this probably won't appear if you haven't loaded the motion file. So you first need to load the motion file and then you can call it here. So what this is basically just going to do is that it's going to set the motion index number to the third motion, which will just do the sit motion, which is this one right here. And then we also want to implement a wait while loop. So basically, so just while the motion status is true, we just want to wait. The reason we need to do this is because if we're gonna do something after for example sitting, the update, basically this update function, all it does is just it keeps running. So we need to make sure that we wait and then we do something else. So for example, let's just call another motion. So we get the motion index number, and now we want it to I don't know, just greet. Let's make it do a push-up. And then of course we need to put the wait while loop. So it's going to do the motion, it's going to wait till that motion ends, and then it's going to do the next motion. If we didn't have these, so if we remove this, you'll notice that it would only do the sit. Now why is this happening? Because this is basically, this start program is just being called a lot of times very fast. So it'll do it'll read this instruction and it'll do the motion, but then it'll also read this one. But since it's still doing the motion, it'll just ignore it and just keep going. So that's why we need to do a wait while, just to wait, do the motion, wait, then do the other motion, and then wait again. In this tutorial, we're going to be looking at how we can perform motions from inside our code. So this is just the example file again, and here you can see, for example, the left jab command. So let's see what's basically happening here. So here we could see that in the second actuator, there are two keyframes up here. There's a keyframe when it gets its hand up, and then when it actually throws a jab. And you can see as I'm moving here that the value of the actuators is changing, and that's basically how this whole thing works. So we can actually set specific values. So for example, here in the code we can see that we've actually copied these values. So for example, here the second actuator's position is negative 95.8. We can actually see here in the goal position part that it's also negative 95.8. It's represented as an integer, as 185. And I'm just going to delete these, and we can set them ourselves. So for example, I'm also going to get, for example, the fourth one. So the fourth one, and I'm going to set its goal position, and then also the third one, or rather the sixth one. So you can set it here. And let's see what values it has. So for example, the fourth one, in the second keyframe, its value is an angle of 20.21 degrees. So we can set that here. I want 20. Oh, 20.21 degrees. It's represented as an integer as 581. And we can also do the same for the sixth one. So for the sixth one, it has an angle of 109.28 degrees. So if we move that here, it would be 128.91 degrees. Okay, so this is basically just setting up our first keyframe, and so when we run it, the arm will do like this. It'll be in this position, but then of course we also want to have another position, which is when the arm is extending. And I'm just going to copy paste this basically, but now we need to set the new value. So in our third position, we want it to be an angle of negative 107.52 degrees. We can set that right here. I completely forgot 107.52. So negative 107.52. There we can see the integer is 145. For the fourth one, it has an angle of 86.43. So 86.43. There we go. And for the sixth one, it has an angle of 12.89 degrees. So 12.89 degrees. And so there they are. So these three instructions are our first frame, and then these next ones are our second frame, or rather our second and third frames. And that's basically all we need to do. Now, as I said in the last video, the board runs this code very fast. So if we actually run this code, it'll just keep running very fast, and it'll probably it'll mess up. It'll either stay here or only go here. So we can just do a wait while loop. So we can put that here. Wait while. So while, well, what do we want to do? We just want to get the controller constant, or I'm sorry, the dynamics of constant. So we can just do here the dynamics of device the is moving flag, and so let's say while the second one is moving, so while is equal to true, we will wait. So what this is gonna do is that it's gonna run. They're basically all running at the same time, so it really doesn't matter if we use the second, the fourth, or the sixth one. We just need to wait. So when it stops moving, then we run this code. If you run the previous code, you'll notice that it works, but there's a bit of a problem because our robot is just falling to the ground. And the reason why it's doing that is because it's not having any torque applied to it. So we can set that through the dynamics of device under torque on and off, and we want to set that to true. So it's basically just going to put force, right, torque into the actuators. Now, which actuators? Well, we actually want to put torque to all of them. So make sure we select all, and that should work. Now that does it's pretty heavy on the robot's battery. So if you don't need it for something, you don't have to do it. But for this example, we can just put it to all of them.